Today's studies are going to be Electrical 101. We're going to talk about everybody's favorite bullshit. This class is going to be a multi-formed class through multiple videos. Today we're going to talk about basic circuits and everything you need to complete a circuit. Here in the classroom there will be puppers. I guess that's the thing. We're putting together the office. So you want to take a look around. Computer, I do Legos and stuff here. Training for work. Helmets there. Big old beanbag chair. TV over there for gaming. And then we just added a whiteboard. This is where we're going to do our lesson. Thank you for joining me. Let's get at it now. So here is a wiring diagram of what a basic circuit will look like. Most manufacturers, when they do draw wiring diagrams, they start from the positive at the top of the page and then work their way down towards the ground. Here's a basic index key of what you would see in different circuits, different things that you'll come across. Fuses will be drawn similar to that. Bulbs and loads will be drawn similar to that. Switches, relays, and then grounds. The basic things you need for a circuit are a battery for the current to come through, a switch or a relay to control the circuit, a fuse to protect the circuit, a load, and then a pathway to ground. These items are all basic circuits. In every circuit that you come across, it'll obviously have a battery. It'll pass through a fuse to protect the car and the circuit. The circuit will be controlled by some sort of switch, and then it'll pass through the load and then the ground. These basic circuits were completed this way for years. They have been changed lately to put the switch on the ground side of the circuit to decrease the load of the switch engaging, but we'll talk about more of that later and what those circuits look like. Now let's start talking about this circuit. You can see on the diagram we'll show the chassis ground coming off the battery, and then your power passing out of the battery down through your fuse, which is based off the current of the circuit, down through your control switch, through your load, which is written as a bulb, and then to ground. So we're going to head ahead, hook our meter up on our negative lead to chassis ground, and we're going to check for power right before the fuse. Find the 12 volts there. Comes directly from the battery, so you always have 12 volts right there. This is a basic schematic of you hooking up a meter showing as the current passes through, leads to the beginning of the fuse, as long as the fuse is intact, to the end of the fuse, and just before the switch will all read the same battery voltage. This just tells you that current can pass through all the way to the switch. Now, since the switch is currently open, that'll show on your meter as 0 volts because it can't pass through the switch. Now that you close the switch, bulb is on, circuit is intact. Connect your meter right before your load, whether operational or not. As long as the switch is closed, you'll see 12 volts as the current passes all the way down through to the load. Dog is being lonely. Damn dogs. Back to what we were looking at. After the load is operational, you'll see about half a volt usually for it to pass through the chassis ground back to the battery. Same test, but there's a break in the ground side. will show that the load's not operational. Follow back even after the load, you have your 12 volts due to the load not being able to consume the voltage because your circuit's not complete with the ground. Now we'll continue with talking about a break before the load in the wire. This will act like a switch. It'll treat the circuit just like this switch was open. It opens here, here, or here, or even in the fuse. If it's shorted the fuse out, it'll treat just like an open. You'll have 12 volts up until you're open. Now we'll talk about why we use fuses. This symbol here signifies a short to chassis ground. And this will cause, due to there not being any load, it'll cause an excess of amperage draw on the fuse, which will pop its internal circuit. And this protects the circuit from finding the next weakest point, which is usually a joint connector or somewhere where a wire was rubbed in, and cause that to not become a fuse and causes fire. Next, we're going to talk about more of how these circuits have grown and evolved over time. Nowadays, we use relays to control high amperage circuits. So we can run thicker gauge wire, but run thinner gauge wire and less of a current through switches than we did before, because they were causing switches to burn up, melt contacts. We also use the switch to move the switch to the ground side of the circuits for the same reason. When the switch was closing, that gap was acting as a load, causing the switch contacts to burn out and cause similar switch failure problems. So more likely than not, this is kind of what you would run into on a circuit. Run from your battery down, a tee off at a junction block or somewhere else, and it would go your pass through. The fuse would be here. I forgot to draw it because, well, shit happens. You'd go down. This would run the magnet side of your relay, and the switch would be on the ground side of the circuit, pass to the chassis ground. When you activate this switch here, turn on that magnet, close this switch here, and pass through your load and into ground. Remember, when you're chasing these circuits, electricity will follow the least path of resistance back to ground. So just because you have an intact circuit, if a piece of electricity can go through shielding or anything to the chassis ground, it will always follow that path back to the ground as quick as possible. So in conclusion of this Electrical 101 class, puppers. You should always have the puppers. But you need 5 things to complete a basic circuit. Step 1 is a battery. This is where your current comes from. It holds the electricity for you. It'll pass through a fuse. This protects your circuits, your wiring, all of the shit. It'll pass through a switch. It'll control the circuit. And a load, what you're trying to command, and then to ground. Any of these items are missing, you do not have a complete circuit and is unsafe. Thank you for coming to Henthorne's Performance Electrical 101 class. Go ahead and comment, like the video if you do. Let me know what you think. We're going to more further in-depth stuff as we go, but this is just step 1, basic circuits. Thank you again.